Okay, so we're just going to continue on with the notes on regular polygon. So we're on example, we're on page 10. Page 10. Okay, so we're still focusing on the pentagon here. So as you can see, everything is on pentagon. The examples are on pentagon. It says here diagonal. So a diagonal, you already know what a diagonal is because we've used that when we talked about the quadrilateral. But here's another word or some kind of a definition again. A diagonal of a regular polygon is a line that connects a vertex. Okay, that's a fancy word for the corner. Okay, it's the vertex to any other non-adjacent. What does a non-adjacent means? Not beside that adjacent, not beside that vertex. So let's take a look at that one. So if we start here, this is called a vertex, which is a corner point. Corner. I'm actually going to try to do a good job here. I'm not going to just sketch it. I'm going to use a ruler. We're going to create a diagonal. So from here, can I create a diagonal from this vertex to this vertex? Is that a diagonal? From here to here. That one is, we can't do a diagonal because it's not right across, right? Because that becomes a side, right? So what about this one? Can I take this from this vertex going down to this one? Is that a diagonal? Yeah, we could make that diagonal. Right over there. So that's, what about this one? Can I take from here again and connect it with this one? Yeah, that's a diagonal. Right there. Now, here, can I take this from this vertex to this vertex? Can I do that as a diagonal? No, right? Because that's a side. That's not a diagonal. Okay, so from this vertex, how many can I have? How many diagonals can I create? 1, 2. Yeah, 2. Okay, good. Now I'm going to move to this vertex. How many diagonals can I make? Can I take it from here to here? Nope. Can I take this from this vertex to this vertex? Yeah, that's a diagonal. Okay, can I take this from this vertex to that vertex? Yeah, that's possible. Good. Oh, it's a star. It's becoming a star. Okay, now I'm gonna move to this vertex. I can't do this one. Can I go from here to here? Yeah, that one. That's that one. And then can I go from here to there? Yeah. Okay, but I've already drawn that one, right? So what does that mean? What does that mean? That means it doesn't end. That means the diagonal from this line, so from this vertex to this vertex, is the same as the diagonal from this vertex to that vertex. Okay, we don't. And then you go to this one. Oh yeah, that one over there too. If I go over here, oh, those two. That's it. And yeah, you will end up with a star. A star. That's fantastic. Star. Okay. So, how many diagonals is that? Did we keep track? Did we keep track? How many is that? 1, 2, 3, 4, 5. 5 diagonals. Okay. Now, this is not bad. We can create it and count them. Okay. Can you imagine creating a diagonal for this one, octagon, or nonagon, or when there's more vertices, more vertex, right? It's going to be a lot. So here's a formula. Here's a formula. How can we calculate, the number of diagonals? So here's the thing. Oops, wrong one. And you can't go wrong here because D means diagonal, right? D, diagonals. What does the n represent? The number of sides. And then here times the number of sides again, minus 3. And then divided by 2. Now, I'm going to try to explain to see why that is. Okay. The n, that's the number of vertices, right? The number of sides, the number of vertices. What about n minus 3? Why is it n minus 3? Remember when we started here, this is the vertex, that vertex. We can't connect it here. We can't connect it here. And we can't connect it on its own. So there are 3 vertices that we cannot connect to. That's why it's minus 3. Do you see that? How many vertices can we connect to? We can't connect it here because that's just the side. We can't connect the vertices to its own. Okay, that's not a diagonal. And then this is also not a diagonal. So it's connected only to 2. And how do we get 2? 5 vertices minus the 3 that we can't connect to. So we're down to just the 2. Is everybody okay with that one? You're taking away the 3. Like for example, this one. How many can it connect to? It can't connect to itself. That's not a diagonal. It cannot connect to this one because that's not a diagonal either. And it cannot connect to this one. That's not a diagonal. So how many diagonals can it connect to? 1, 2. So from 5 vertices, you can only connect 2 to 2. What about dividing it by 2? Where did that come from? Right? Because sometimes, I want to make sure that we understand what formula, the formula that we're using in here. Earlier I said that if you're starting from this vertex to this vertex, that counts as 1, right? That's 1 diagonal. But then when I move to here and I connect from this vertex to that vertex, that's 2 diagonals. Well, we don't want to count it twice. We don't want to count it twice, so we have to divide it by 2 so that it's only counting once. Okay. So for example, here, we can connect it here. That's 1 diagonal, but then when you get to this part, we're going to take this connecting there. So you don't want to count it twice, so you have to do dividing by 2. Okay? So we said it's 5, right? So let's see if it is 5. D is equals to n times n minus 3 divided by 2. Okay, so we're going to substitute the values in. So n, how many sides? 1, 2, 3, 4, 5. 5 sides. N minus 3, so it's 5 minus 3 divided by 2. Okay. So I'm just going to go over here. So we all remember the orders of operation, right? Orders of operation. So we said we're gonna figure out what's inside the brackets first. So 5, and then 5 minus 3 is 2, divided by 2. And then 5 times 2, that's gonna be 10, divided by 2. And then finally, 10 divided by 2 is 5. So our answer, there are 5 distinct diagonals. 5 distinct diagonals. Good? Oh, this one's an easy one. Yeah, yesterday we kind of talked about line of symmetry. Symmetry is a mirror image. So it says here, a line of symmetry is, in a regular polygon, is a line that splits the polygon in exactly half so that there are 2 identical but opposite shapes on either side of symmetry. So it's like a mirror image. So below is a diagram showing a pentagon. Okay, again, pentagon. So one line of symmetry is shown, so this one. So you can take a pair of scissors or a knife, and then you can cut it in that line, and this half is a mirror image of that half. Yeah? You see that? Is that the only one? Can you see another one? Another line of symmetry? Okay, so it's, how do you, what do you see?
Let's say from the...
Do you want to go up and then try it there on the board? Yeah, that's perfect. Is that correct? So if we cut, so this is what we have here. That's what Delmar had said. If I take a pair of scissors, is it symmetrical? Now you probably, oh yeah, that might be a better idea, to kind of spin it and then we see it better, right? Yeah. Okay, can you see another one? One more? Okay, can I spin it one more? Okay, I'm gonna, sorry, I dropped my ruler. So if I spin it like this, we can see, oh, I see. I can take from here to here. Oh, we found another one. Another one. Okay, let's do it. So I turn it some more. How many do we have so far? So I turn it some more. Okay, I'm gonna. 4. So I can cut it this way, and then this side and that side, and you can see one more. Yeah. Okay. If I turn it a bit more, like this way. Yeah, we can. Right there's your. Whoa, so how many is that? Did we keep track? 5. Yeah, there's 5. So there's 1, 2, 3, 4, 5. And I'm not gonna count this because it's the same one, right? So count it from here. 1, 2, 3, 4, 5, because this one is the same thing as that one. So yeah. So how many lines of symmetry. There's 5 lines of symmetry. Okay, well, is there some kind of a formula to this? Well, here's the thing. Notice that when you're done, you have the same number of lines of symmetry as the sides of the polygon. So if there are 5 sides, there are 5 lines of symmetry. If there are 6 sides, there are 6 lines of symmetry, and so on. Okay? So, Townsend. So here, the same number of lines of symmetry as the sides of the polygon. How do you like that one? You okay with that? So let's take a look. Oh, what does it mean by backwards question? Let's see. Backwards question. It says here, determine the number of sides of a regular polygon that has a central angle measuring 45 degrees. Okay. Now this is backwards because we know the central angle, we just don't know what kind of polygon it is, and we don't know how many sides there are. So central angle, what's a central angle looks like again? Central is equals to 360 divided by n. Okay, so that's the formula for the central angle. Central angle is equals to 360 divided by n. What did they give us? Central angle is measuring 45 degrees. So 45 degrees here. Okay, good. So what does that mean? We're going to try to figure out n. We're going to try to figure out n. That means 360 divided by something will give you 45. So what number, 360 divided by something number, equal to 45? Oh, you don't? Okay, talking to yourself. Okay, talking to yourself is okay. I do that all the time. Now, remember, n has to be a whole number, right? Whole number. It's either 1, well, it can't be 1 because 1, you can't have a polygon with one side. Can it be 2? No, you can't have a polygon with 2 sides. Can it be 3? Okay, because if you go 360 divided by 3, that's going to be 120. So that can't be it. Okay, 360 divided by 3. Oh, no, it's 120, not 45. Okay, what about 4? 360 divided by 4. Nope, that's 90. We go 360 divided by 5, 72. Oh, we're getting close and closer. Oh, where did I stop? Is it 5? Mm-hmm. Okay, 360 divided by 6. Oh, even closer. 360 divided by 7. Oh, no, it's not that one. 360 divided by 8. 45. There you go. There's your answer. That means n has to have 8 sides. 8 sides. Okay? And that 8 sides is called octagon. Octagon. Can you think of another way? Octagon. Octagon. Can you think of another way besides trial and error to figure that out? Okay, so that's one strategy, and that's okay. We can figure it out by trial and error. But can you think of another strategy to figure out the n? I thought I heard somebody say it, but would you like to share it? I thought I heard you say it. Yeah, cross multiply. It is cross multiply. I thought I heard you say it. Yeah, we're gonna cross multiply. So this one denominator is 1. So we're gonna cross multiply, right? So that becomes 45 times n equals 1 times 360. Okay. And then we're gonna try to solve for n. So divide by 45 to cancel that. So n is equals to 8. 8 sides. 8 sides.
Do we have to do that side?
Which one? This side?
Yeah.
This way?
Or is that just a second way?
That's just another way. Yeah. So you could, this one here, you could do trial and error. That's perfectly fine. That's a trial and error is a strategy, right? Trial and error is a strategy. A lot of people think that it's not a strategy, but it is, right? Because we understand that n has to be a whole number, right? You can't have half a side, right? And the n has to be a whole number, right? 3 or more. Good? Let's take a look at the example 2. Again, they call it backwards. Well, let's see what how backwards this is. Determine the number of sides. Okay, I already see it's backwards. Determine the number of sides of a regular polygon. Because we don't know what kind of polygon it is. But we know it's a regular polygon, so that's good. Where the sum of interior angle is 720. Okay, sum of interior angle is 720. Okay, so how do we figure out the sum of interior angles? It's going to be S is equal to 180 times n minus 2. That's our formula, right? The sum of interior angles is 180 times n minus 2. So, what does it say? It has to be 720. The S has to be 720. Now let's do a trial and error, because trial and error is a strategy. Okay, so let's just try this. Let's just try. Anybody would like to make a guess on what the n value is? 6. 6? Okay, so we'll try 6. Did it work right away? Okay, we'll pretend we don't know. let's try 7.
Okay.
Let's try first 7. Now, if n equals to 7, okay, I want to show you that, trial and error is good. If n is 7, what would it be? 180 times 7 minus 2, that's going to give us 180 times 5. That's going to give us 180 times 5 900. That's too much. That's too much.
Okay, never mind, I was wrong.
Okay. That's too much. Okay, too much angle. So we have to, let's try 6. Now let's try 6. Try. We're gonna try another one. Let's try 6. Okay, now if n is equal to 6, let's give it a try. 180. Okay, I'm using the formula, so that's where that thing is coming from. 6 minus 2. Okay, so that's going to be 180 times 4. Oh, there it is, 720. Okay, so 720. So, oh, now I got it. So, but we have to write down our final answer. So what's our final answer? How many sides does it have? How many sides does it have? I'm going to try to look for a nice brighter pen. Okay, well, this is not quite bright. Okay, because remember, this is 180 times n minus 2. Remember, the n tells you how many sides. So how many sides are there? 6 sides. Yeah. So there are 6 sides in this polygon. Okay. Not 4, right? Not the 4. Because remember, it's n minus 2. Good? So far, so good. That's one way. Now, trial and error is one way. Let's do a different one. I'll show you a strategy on how to solve that algebraically. Okay? So we know it's 720 degrees. Let's try a different one. 720 degrees is equals to 180 times n minus 2. Okay, so here's another way. What we're going to do is we're going to work backwards to solve for n. What we're going to have the n alone. Another word that we said, isolate. Right? Isolate means have it alone. So how can we have it alone? Well, what's happening here? 180 times all of these. Okay. So the first thing we got to do is I got to get rid of this 180. Okay. But right now this 180 got multiplied in. So what I'm going to do is I'm going to do the opposite. Divide by 180. Divide by 180. If I divide 180 here, I have to divide 180 on the other side as well. Okay, because we're making them balanced equation. So this cancels, that's gone. Then 720 divided by 180. Well, how many is that? 720 divided by 180. That's 4. That's 4. Okay, so 4 is equals to n minus 2. Okay. Now, the n is not quite alone yet. It's not isolated yet. What's happening to n? N is getting subtracted by 2. So, to get rid of that, we have to do the opposite. Add 2. And if I add 2 here, we got to add 2 to the other side to maintain the balance. So minus 2 plus 2 cancel out. That's gone. We're left with n, and then 4 plus 2 is 6. 6. Okay. So your n is 6. And we did that. We got the same answer as the trial and error. Which one do you like better? You like the trial and error? Or you, doesn't matter, right? Those are both strategy. Okay, now they're saying it's another backwards question. Let's see how backwards this is. And they're already telling us challenge question. Oh my goodness, challenge question. Now when you see in any textbook, when you see, oh, this is a challenge question, like, or what, I don't know, my instinct is to say like, I don't know about that, that's too challenging for me, I don't want to try it, but we'll give it a try. All we wanted to do is just try it, give it a try. So there we go. Determine the number of sides of a regular polygon that contains 35 diagonals. Oh my goodness, 35 diagonals. That's okay. Make a guess. Trial and error. Let's give it a try. What should we try?
I think it's gonna be a circle.
A circle? It has to be a polygon. There has to be some kind of vertex to it. Okay. Give me a number. Any number. Hopefully it's not the right number. Okay. Well, first of all, what's a formula that we have? What's a formula that we normally use to figure out the diagonals?
D equals 35 minus n, or no,
Oh, okay. You're telling me D is 35 here. Okay. Yeah. Okay. Yes, I know we're. No. Okay, I'm just gonna go like this. 35 is equals to n times n minus 3 divided by 2. Yes? Okay, so whatever the n value is, and we gotta put it in two different spots. Remember, we got the n here and the n inside the brackets. Okay, so what number do you guys want to try? Okay, let's try. It doesn't have to be. We're gonna try whatever. So we're gonna try. If n equals to 6, what would happen? So you're thinking about it's a 6-sided polygon. Okay, so it's gonna be 6 times 6 minus 3 divided by 2. Okay, I'm just gonna go this way here. 6. Let's do this on our calculator. What would this be? So 6 brackets times 6 minus 3 divided by 2.
34.5.
I'm gonna figure out the top. So 6 brackets 6 minus 3. I gotta close the brackets. Oh, I said I'm gonna close the brackets. I didn't listen to my own voice. Divide by 3. I got 6. Oh, okay. Okay. Oh, did I type it wrong? So 6 times 6 minus 3, close brackets, divided by 2 is 9. 9, okay, 9. Oh, okay, whoa. So that means if I have a 6-sided polygon, regular polygon, and I try to figure out how many diagonals, it will have 9 diagonals. Oh, okay, you got that one. What do we need to get? We need to get 35. Okay, so we need more. How do you get more diagonals? You need to have more sides, right? Okay, so so this is not a go. Okay, let's try a different number. Anybody want to say or a guess? Throw in a guess.
12.
12? Okay, let's give it a try. Let's try 12. Now, let's try 12. What would it be? Okay, I'm going to follow this formula, right? So it's going to be 12 times 12 minus 3 divided by 2. Okay, so 12. Oops. 12 times 12 minus 3, close brackets, divided by 2. 54. Okay, 54. What's your instinct saying? Too much. Okay. So 6 is too little, right? Because we only got 9. But 12 is too much. We got 54. We want to do 35. Okay. Let's try another one. 10? Okay, let's give it a try. Now what if it's 10? 10. So if n equals to 10, 10 sides. So 12, oh, jeez. No, not 12, 10. 10 times 10 minus 2 minus 3. I'm trying to rush this question. 10 times 10 minus 3. Okay, following the formula. Divide by 2. Is that the one? Let's see. Yay, we got it. 35, we got it. So we got to state our final answer. So how many sides are there? There has to be 10-sided. What's a 10-sided polygon? What's the name for it? Go back. What's that called? It's called decagon. Decagon. Okay. Now, this thing, I can't. Oh no, let's try making this as a. So this is a trial and error. Okay, so this is a good one. That's a strategy still. Okay, so don't think that that's a strategy. It is. How can we do this algebraically and logic at the same time? So here's gonna be. Oh, before you go, I want to give you the thing. Are you going? Or okay, come here and then get this paper. Yeah, I want you to forget about it, or I don't want to forget about it. It's just it's flipped down, I think, underneath that paper. Yeah, there you go. You got it. Okay, so how can we solve this kind of like algebraically slash logic? Okay, so we're gonna take a look at this. Let's try to solve for n. So cross multiply. So that's going to be 2 times 35. That makes it 70. Now, something times something minus 3 will give you 70. Something times something minus 3 is 70. Can you think of? That's gonna give us, this one has to be 10, and then this is gonna be 10 minus 3, which is 7, right? That's the only number that you could create to make a 70. Okay, so to cross multiply that, that gives you all of the lines. Okay, remember, from one vertex to the other, 1 and then 2. So you're counting it 2 times. So going from one vertex to this vertex and then this vertex to that vertex, that's counting it twice. That's why it makes it 70. So if you cross multiply there, and then you look for a way, say, okay, what number can I multiply together to give you 70? It would be n times n minus 3. Okay. So that's great. That finishes our unit here. It's done. So what I'm gonna do, yeah, we're almost at the end of the class anyway. Before you go, I am going to give you the take-home test. Okay? Take-home test.